Hey guys, welcome to another video of your favorite cloud learning platform, K21Academy, where you learn cloud from the experts. In this video, our expert trainer will be talking about building globally distributed databases with Cosmos DB.
We have taken this clip from our step-by-step learning program on data engineering on Microsoft Azure DP-203. Guys, make sure you watch the entire video so you can avail the free gift at the very end. Now, let's hear from our expert.
Hey guys, how are you? Welcome back. And now we are coming to module number 4. As part of module number 4, we are talking about Cosmos database. And we'll understand what's the meaning of Cosmos database, how do we create it, how do we query the Cosmos DB, how do we create any application in Cosmos with Cosmos database. So lesson number 4 is optional. It's not part of your certification as such. It's just FYI information. And we'll also talk about distribute your data globally with Azure Cosmos DB. Right? So let's get started. So the very first thing is lesson number 1, what is Cosmos DB? So what is DB account, what is request unit, what is partition key? So we understand each component is an element of Cosmos database. So just FYI, Cosmos database is a very highly scalable, globally distributed database. So in the starting, when we create the Cosmos DB for the first time, it is having one endpoint. So you can see that here, one Cosmos database account is getting created. So account is more like a wrapper, and inside the wrapper you can have multiple databases. So once the account is created, you can select the multiple regions in the world where you want to make your endpoint. So maybe if I have a distributed data application, so one of my endpoint can be South India database, South India data center. Another endpoint of Cosmos database can be West India data center, or another can be in East US, another can be in UAE Central, UAE North maybe, or another endpoint maybe in West Europe. So the application might be globally distributed and having all these databases are syncing with each other, and wherever the customers are, the applications are pointing to the nearest endpoint. So if any company requires database which is globally distributed, then Cosmos DB comes into picture. Now, something which I want to talk about over here is scalability. It's you can say we have options such as autopilot. Autopilot means as per the requirement, automatically Cosmos DB will scale out, scale in. So it's highly scalable. When it comes to performance, couple of numbers I want you to remember. So when read latency comes into picture, read latency is less than 10 milliseconds. When we talk about write latency, write is less than 15 milliseconds. So remember these two numbers, and like how performant is Cosmos database. It's highly available. It is having multiple endpoints globally. So when it comes to availability, even if one of the endpoint goes down, we have more endpoints available from where we can read. So it's like active sites are there, and it's pretty high available. And SDK is available in all the programming languages with which you can create applications using Cosmos DB. So I'm taking back you to the next slide, and this is the account page. How do we look and feel like? How does it look and feel like? And in the lab, we will be creating it, right? So you have to hang in for the hands-on part. Now, before I go ahead, I want you to understand something pretty important over here. There are 4 things I want you to understand, or maybe so let me use Microsoft documentation for that purpose. Now, check this out over here. Now, we have various type of non-relational data stores are there. One of the data store is called as key value pair, and this is how the key value pair looks like. So if I want Cosmos database to become a key value pair and store information in key and value format, then I will select, you see this option over here, API, SQL API, right? So in this option, in the drop-down menu, we will select table API. So if you select table API over there, it will become key value pair, and the information will be stored in this format. Secondly, if I want document database, right? A lot of times you can say document databases are pretty easy to work with, schema-less, and you can say very flexible as such, and schema will be imposed on read, not on write. So you can write very fast as well. So if I want Cosmos database to behave like document database, I have 2 options which I can go for. First option is I can leave it like SQL Core API, or I can select MongoDB API over there. So if I select Cosmos DB with SQL API, it is compatible with SQL. So SQL queries can run over there. If I select MongoDB API, it is still a document database, but now Mongo queries can run over there. So apart from this, this is called as graph database. So if we select Gremlin API while creating Cosmos database, this is how it stores information in graph format. And similarly, we have column family database. So if we select Cassandra API, this is how it stores information in column family. You can say in column family database like that. And the example of one column family database in the world is called as Cassandra. So these are various modes of Cosmos DB. So if somebody says that Cosmos database is multimodal, the meaning of that is it can have multiple modes like that. Like it can have various ways in which it stores information. It's a non-relational database, but it can store information in multiple ways. Graph database, graph manner, key value pair, document DB, or column family database like that. Now, how do we pay for it? So remember this line which I'm saying, one request unit is equal to the amount of resources required to read 1 KB of document in 1 second. Remember this. So if I have 1 KB of document, I want to read that in 1 second. So I have to provision one request unit to do so. So if I have 400 KB of document, and I want to read 400 KB of document in 1 second, I need to provision 400 RUs over there. Remember this. So what is request unit? See, now if in infrastructure as service, we have RAM, CPU, IOPS, and so on and so forth, by which you can provision resources or provision in database terms. You can provision, let's say, throughput over there, read and write. How much can we read, write per second? However, now Cosmos database is not infrastructure as service. It's more like a platform as service, globally distributed database. So what did they do? They gave you one new term, and the new term is called as request unit. And request unit means amount of resources. Amount of resources can be any resource: CPU, RAM, IOPS, storage, anything behind the scenes which is required for you to read or write with some sort of can say throughput. So we pay in request unit. So you can assign request units to your database or the containers, and you will be able to read, write accordingly. So if you try to read more than what is allocated, obviously we are supposed to get some error, and the error which we get is called as 429. So 429 basically means rate limit, upper limit hit. So what do? Either we give more resources to Cosmos database, or we simply enable autopilot over there. Autopilot means that it will automatically scale out, scale in. That's a pretty interesting functionality. Now, whenever databases comes into picture, partitioning will be there. And so one of the art of any database administrator or data engineer will be in terms of how to select the partition key. Now, if I select the wrong partition key, my queries will not be optimized. If I don't do partitioning, it will be pretty, you can say pretty bad. If I select the right partition key, and there is no thumb rule as such. For every time, you can say for every scenario, every type of data, every type of queries, the partition key can change. So what do? We do a reverse engineering. First of all, we go and check out what type of queries will be running. So maybe let's say I have 10 queries which are running over there. So we cannot make everyone happy. We can make maybe 70% of the people happy, or maybe 80% of the people happy. So out of, you can say 10 queries as such, you will try to do the partitioning in a manner which can keep 6 to 7 or maybe 8 queries happy in that particular sense. So you can see why do we have partition? Why have a partition strategy? Having a partition strategy ensures that your database needs to grow so it can do easily and continue to perform efficiently. Continue to perform efficient queries and transactions. What is partition key? Partition key is the value by which the Azure organizes your data in the logical division. And these logical divisions are behind the scenes in physical partitions. Range of values: the more value your partition key has, the more scalability you have. But remember one thing, do not select a partition key which is having very unique value. For example, like cell phone as such, or primary key of some sort of, or having too unique. If the uniqueness of we call this cardinality as such, high cardinality values. So if the keys are not repeating, then your data will be too distributed, and that's also a part of wrong partition strategy. During the session, I will explain more about partition. I'll take more time into explaining it using whiteboards and so on and so forth. However, so as you're just discussing about to determine the best partition key for read heavy workload, review the top 3 queries out of the 5 queries we are planning to do so. Do a reverse engineering and do the partitioning accordingly. Transactional workload. For write heavy workload, you need to understand the transactional needs of your workload. How are we doing the transactions as such? And based on that, we do the partitioning key choosing. Now, inside Cosmos database account, you have the database over there. Now, Cosmos database is equal to database in relational database sense. In SQL, you can imagine like that. And container is equal to table in a relational database. So if you understand what is SQL, you have seen, we understand what is SQL, right? SQL is basically having some sort of databases and tables are having rows inside there and so on and so forth. So container is equal to table and rows is equal to documents. Container is equal to table and rows inside a table is equal to documents inside container. Remember that. And database is equal to database. So we create databases, we assign the throughput over there, we specify the containers, and these containers are having some partitions, and inside that we store our data in some sort of manner, like documents might be there. So let's have a quick revision and a couple of more figures I want you to understand. So check this out. So you want to ensure there is 99.999% availability for read and write of your data. How can this be achieved? So what we can do, we can configure multi-region accounts and we can do multi-region writes as such. So you just need to enable multiple Cosmos DB endpoints, and then that high availability will, you can say, then the .9s will increase. What are the main advantages of using Cosmos database? Now, main advantage of Cosmos database is basically that it is global in nature. Multiple modes are there. Availability, minimum availability is 99.99. And latency is pretty good. In around tens of milliseconds latency is there, and actual numbers will be can say read latency will be less than 10 milliseconds and write latency is less than 15 milliseconds, to be in exact numbers like that, in that particular sense. So Cosmos DB offer global distributed capabilities out of box, and it is minimum availability of 99.99%, and response time of read-write latency is typically in the order of tens of milliseconds, right? And remember that actual numbers less than 10 milliseconds and less than 15 milliseconds over there. In lesson number 2, we have a look at what type of queries are there. And in the lab, you will run more queries, but have a look at them. So basically the queries are example over here. Select there, you can see it's pretty similar to SQL query, right? Exactly. So this is where when we create Cosmos DB with SQL API, you can run SQL queries against Cosmos database. So select star from products where p.id equal to 1, and select p.price and so on and so forth. So this is basically how do we do the queries against SQL database. Similarly, we do it over here. So check this out. Now we have stored procedures and we also have user defined functions. Both the things are there. And so what do we do? So what is stored procedure? Basically, stored procedure performs the complex transactions, and stored procedure same as what we have in any other type of database as well. So stored procedure perform the complex transactions on documents and properties. Stored procedures are written in JavaScript and are stored in a collection on Azure Cosmos DB. So stored procedures are stored as in the collections as such, and they are written in JavaScript. Now, user-defined function is different. User-defined function is in any programming language, the way we define the functions and then we use that inside the code. That the same concept here also lies. So user-defined function, they extend the Cosmos database query language and implement custom business logic and as calculations on properties and documents. So for example, let's say you can say that if I want to create some sort of maybe one function which is going to be used again and again inside the code. So one logic needs to be repeated again and again inside the code. So I can write a function and I can keep on calling the function. So similarly, user-defined functions, we can keep on calling them as part of the SQL query language. Let's have a couple of questions over here. Check this out. So you are a data engineer wanting to work with data that is currently stored in table storage account located in West US region, available globally. which Cosmos data model should you go for. So basically they're looking for table storage, and table is key value pair. So we are looking for table API like that. Now, which type of data model provides a traversal language that enables connection traversal across connected data? Basically, we are looking for graph database, and graph database we run Gremlin queries or Gremlin API against that. So answer will be Gremlin over there. Now coming over to lesson number 3. Lesson number 3 is about building a .NET application that can communicate with Cosmos database. And lesson number 3 is optional. It's not part of the certification. However, hang in with me and understand a couple of information over here. So Cosmos database can also be created using VS Code or Visual Studio. We have extensions in VS Code by which the Cosmos database packages are installed in VS Code. VS Code is the free IDE from Microsoft, and then you can see in the screen left hand side everything is listed, and you can create inside the account, you can create databases and containers and documents inside that. As part of Azure Cosmos Database SQL API client library for .NET, various methods are available by which you can do operations with Cosmos database. And we can create documents, we can read documents, we can replace document, we can do upsert. Upsert is basically insert plus update, and we can delete documents asynchronously. Here we have some examples of how do we do query against the Cosmos database programmatically. So using .NET SDK, FYI, when we do the CRUD operation, link queries are used, and there are multiple methods by which you can run the queries, and the queries can be run with the SDK, or you can run direct SQL syntax against the database as well. So you can see select star from user where user.lastname equal to the last name of the user. Console.writeLine can be used to print out the outputs. So a couple of questions as part of the review questions over here. Suppose you are using Cosmos database to develop .NET Core application. Then access Cosmos DB, you need to include connection string for your database in your application, which is the most convenient way for you to get this information in your project. We can directly work with Visual Studio Code. When you are working with Cosmos database SQL API, which of these can be used to perform CRUD operation? They are basically link queries. So when working with Cosmos database client SDK document class, you use a NoSQL model. How would you use this class to change the first name field of a person document from Anne to Fran? Basically, there is an option which is called as replace document, and we can call replace document, and we can update the person information over there, the person object as such. So we can call the replace document asynchronous method, and with a update person object, we can update it. Coming to lesson number 4. As part of lesson number 4, we'll talk about how does the data gets distributed globally, and we'll learn about the benefits of writing and replicating data to multiple parts of the world, Cosmos database multi-master replication, Cosmos database failover management, and how can we change the consistency labels over there. So this is basically how you can say, so it's a very graphical method. So in case you have worked with any database before, when we used to create multiple endpoints, we open, let's imagine we are doing some sort of you can say let's say multiple nodes are to be added as part of SQL database. It's a very gray looking wizard. We open always on, and then we create those multi-master. Now in the cloud, it looks like that. You simply have to click on any of these options over here and just save the option from the top, and multiple endpoints in the world will be created, and you have to select whether you want write to be enabled. So if I say write, then all of them are master databases or multi-master, multi-write global. And if we want, we can also have single write and multiple read copies as such. So my customers might be globally distributed, and because of that, I'm using Cosmos database with multiple endpoints in the world. And one thing I wanted to remember is that there are homing APIs. Homing API means that whenever, so even if we have, let's say 5 endpoints over here, the endpoint URL will not be different. It will only be the Cosmos DB single URL, and the application is always pointing to the nearest endpoint. So if my customer was in West US and now the customer travel to Japan geography, so the application will automatically start pointing to Japan endpoint. APIs are homing. They always go to the nearest endpoint. So the question that should come to your mind is, how is data consistent? We have various consistency level, like strong consistency is one of it. So if I have a strong consistency global, then if any update is done, then changes happen in all the endpoints, and then you can say then only it is read. So even it does not matter whether you're pointing to West US or Japan West, your data is always consistent. It is available in all the endpoints. And Cosmos database master application happens globally and in both the direction. So from one endpoint to another, and so on and so forth like that. When we talk about Cosmos database failover, there are multiple, we can say automated failover is also there, and manual is obviously available. Automated failover is a feature that comes into play when there is a disaster and or other event that takes one of your read or write region offline. It redirects queries from the offline region to the next prioritized region. You can also specify, like, if this goes down, then where the query should go, or it should automatically can also be resolved. Read region outage. Azure Cosmos database with a read region outage is one of the in one of the affected regions are automatically disconnected from their write regions and marked offline. And when write region outage happen, then if the affected region is the current write region and automatically failover is enabled, then the region is automatically marked as offline, and alternate region is promoted as write region. So even if there is a read region outage or if there is a write region outage, we have automation around that in terms of failover management. Check this out. So now a couple of interesting things over here. We have multiple type of consistency levels. First is called as strong consistency, the one which we are talking about. So strong consistency means that if I have multiple endpoints in the world and if I am updating my data in one of the endpoints, then data will sync first into other endpoints and then only it's available for read purpose. In strong manner, it's okay to wait, but all should be consistent. Secondly, we have another consistency called as bounded staleness. Bounded staleness can be done in two methods. You can do time-based staleness, you can do version-based staleness. So if I set the version of staleness equal to 5, then what will happen if multiple transactions are going on? Let's say A, B, C, D, 1, 2, 3, 4, 5, like that. And you have specified staleness to be 5. Then right now, maybe you can say transaction number 5th is going on, or it is already committed, but because there is a staleness of 5, you are reading 5 version old data. So if the data is having 5 versions, maybe earlier the value was 1, then it was updated to 2, then it was updated to 3, then the value was updated to 4, and was updated to 5, and so on and so forth. So you are reading 5 version old data. So bounded staleness is strong consistency with a staleness. The staleness can be defined in version or can be defined as time over there. If you specify that I want all the data to be 30 minutes old data, then what happens? Globally, everyone is reading, you can say 30 minutes old data is being served to everyone globally, right? Maybe the data is still, you can say, updated, but old data is getting served as such. So strong with a staleness. Now, session consistency is the default consistency. It means that you will always read your own writes. Remember this line, read your own writes is session consistency. There is another called as prefix consistency, and prefix consistency basically means that the prefixes are consistent or the timestamps are consistent. So the fifth one is called as eventual consistency, and in eventual consistency there is no order maintained, there is no timestamp maintained. So let's say we both are using any chat application to chat right now. Chat application might be like WhatsApp. So let's say I'm using WhatsApp type application. I say hi, I say sent, hello, sent, how, sent, are you. So the order of transactions or the order of my chat with you is hi, then hello, then how are you. So in eventual consistency, what will happen when you read it? It's possible that how will go that it was supposed to say hi, hello, how are you. So hello went first, hi is coming afterwards, you came first, then R is coming afterwards. Now all the transaction, all the order got messed up. That is very possible to happen when eventual consistency is there. But if there was prefix consistency or the previous one, the fourth one, then hi, hello, how are you will go in the same order in which I have sent them. You will receive in the same order. That's the difference between both of them. So now we have one question over here. You want to maximize the data integrity of your data. that is stored in a Cosmos database, which consistency level should you go for? So we want to maximize the integrity, so it will be strong consistency, right?
We have put on everything about the certification and a lot more on this 12-week roadmap that we have created for you if you are preparing for Microsoft Azure Data Engineer Certification DP-203. On week number 1, we start with explore compute and storage options for data engineering workloads. Then on week 2, we cover run interactive queries using Azure Synapse Analytics serverless SQL pools. On week number 3, we cover data exploration and transformation in Azure Databricks. On week number 4, we cover explore, transform, and load data into data warehouse using Apache Spark. On week number 5, we cover ingest and load data into data warehouse. On week number 6, we cover transform data with Azure Data Factory or Azure Synapse pipelines. On week number 7, we cover orchestrate data movement and transformation in Azure Synapse pipelines. On week number 8, we cover end-to-end security with Azure Synapse Analytics. On week number 9, we cover support hybrid transactional analytical processing with Azure Synapse Link. On week number 10, we cover real-time stream processing with Stream Analytics. On week number 11, we cover create a stream processing solution with Event Hubs and Azure Databricks. By week 11, we are pretty confident that you are ready for the certification exam. So to top it all off, on week number 12, we help you with some tips and resources for clearing certification and CV preparation, along with some exam questions and interview questions. Guys, this is an excellent training program that we have created specially to meet your needs as you are preparing for the certification exam. If you are interested in this training program, then I would highly recommend you to go and attend our free class on Microsoft Azure Data Engineer Certification. In this free class, we will be covering what is Azure Data Engineer role and exam DP-203, why everyone is working on data currently, important Azure services you should learn, and there is going to be a live demo as well on Azure Synapse Analytics components. To register for this free class, go at K21Academy.com/AzureDE02, then select an event date, your name, your email ID, your phone number, and then click on Yes, Save My Seat. Once you click on this button, you will be redirected to this particular page. That means you have successfully registered for this free class. Now, guys, I'll see you guys directly at the free class.